Good day everyone, we are from Group 2. We will present Chapter 3 about the Enhanced ER Model. Group 2 consists of Maizarfan Fajri and Adinda Putri, next Surya Mulya Harmawan, and then Arbi Abdullah Saleh, then Muhammad Al-Amien Fadilli Rasyif, Imam El Hafiz, and last Reyhan Akbar Putra Permana. Here are some objectives in Chapter 3. First, define terms. The first term is Enhanced Entity Relationship or EER model. What is EER model? EER model is a model that has resulted from extending the original ER model with new modeling constructs. Next, subtype. What is subtype? Subtype is a subgrouping of the entities in an entity type that is meaningful to the organization and that shares common attributes or relationships distinct from other subgroupings. Next, supertype. Supertype is a generic entity type that has a relationship with one or more subtypes. Then, attribute inheritance. Attribute inheritance is a property by which subtype entities inherit values of all attributes and instances of all relationships of their supertype. Next, generalization. Generalization is the process of defining a more general entity type from a set of more specialized entity types. Then specialization. Specialization is the process of defining one or more subtypes of the supertype and forming supertype or subtype relationships. Next term is completeness constraint, which means a type of constraint that addresses whether an instance of a supertype must also be a member of at least one subtype. Next, total specialization rule. A rule that specifies that each entity instance of a supertype must be a member of some subtype in the relationship. Next term, partial specialization rule, which means a rule that specifies that an entity instance of a supertype is allowed not to belong to any subtype. Next, disjointness constraint, which means a constraint that addresses whether an instance of a supertype may simultaneously be a member of two or more subtypes. Next, disjoint rule, which means a rule that specifies that an instance of a supertype may not simultaneously be a member of two or more subtypes. Next, overlap rule, which means a rule that specifies that an instance of a supertype may simultaneously be a member of two or more subtypes. Then, subtype discriminator, which means an attribute of a supertype whose values determine the target subtype or subtype. Supertype or subtype hierarchy, which means a hierarchical arrangement of supertypes and subtypes in which each subtype has only one supertype. Next term, entity cluster, which means a set of one or more entity types and associated relationships grouped into a single abstract entity type. And last term is universal data model, which means a generic or template data model that can be reused as a starting point for a data modeling project. Next learning objective will be presented by Fajri.
Okay, I will talk about supertype subtype relationship. Supertype is an entity type that has got relationship with one or more subtypes and it contains attributes that are common to its subtypes. Meanwhile, subtypes are a subgroup of the supertype entity and have unique attributes, but they will be different from each subtype. Here is the example of the supertype and the subtype relationship. In this picture, the employee is the supertype or the parent entity, and the full-time employee and hourly employee are the subtypes. The subtypes inherit all supertype attributes. Like employee will have employee first name, middle initial, last name, etc. And subtypes have attributes that are different from other subtypes. Full-time employee have attribute health insurance update indicator, Meanwhile, the hourly employee have attribute billing rate per hour amount. Next by Reyhan.
Generalization and specialization. First, I will explain about generalization. Generalization is the process of defining a more general entity type from a set of more specialized entity type, or we can call it as a bottom-up process. And the second one is specialization. Specialization is the process of defining one or more subtypes of the supertype and forming supertype or subtype relationship, and we can call it as top-down process. I will show you about the example of generalization. As we can see in the figure 3.4, there is three entity types, which is car, truck, and motorcycle. These three entity type has a common attribute, such as vehicle ID, price, engine displacement, and vehicle name. Suggests that each of the three entity type is a really version of a more general entity type. This more general entity type named vehicle, together with the resulting supertype or subtype relationship, the entity car has the specific attribute, which is number of passenger, while truck has two specific attribute, which is capacity and cab type. Generalization has allowed us to group entity type along with their common attributes and at the same time preserve specific attributes. You'll see that the only attribute of motorcycle are those that are common to all vehicles. There are no attributes specific to motorcycle. So there is no need to create a motorcycle subtype. Next is the example of specialization. Figure 3.5 shows an entity type named part, together with several of its attributes. The identifier is part number, and other attributes are description, quantity on hand, location, routing number, and supplier. We discovered that there are two possible sources for parts. Some are manufactured internally, and others are purchased from outside suppliers. Further, we discovered that some parts are obtained from both sources. Some of the attributes in figure 3.5a apply to all parts, regardless of source. However, others depend on the source. Routing number apply only to manufactured parts, whereas supplier ID and unit price apply only to purchased parts. This factor suggests that parts should be specialized by defining the subtypes manufactured part and purchased part. In figure 3.5b, routing number is associated with manufactured part. The data modeler initially planned to associate supplier ID and unit price with purchased part. However, the data modeler suggested instead that they create a supplier entity type, an associative entity linking purchased part with supplier. And next is combining specialization and generalization. Specialization and generalization are both valuable techniques for developing supertype or subtype relationship. The technique that we use at a particular time depends on several factors, such as the nature of the problem domain, previous modeling efforts, and personal preference. You should be prepared to use both approaches and to alternate back and forth as dictated by preceding factors.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Arbi Saleh. I'm from Management Batch 2018, and I want to explain you about LO number 4, which is specify both completeness constraint and the disjointness constraint in modeling supertype or subtype relationship. Constraint in supertype or subtype relationship. Completeness constraint is a type of constraint that addresses whether an instance of a supertype must also be a member of at least one subtype. Total specialization rule is a rule that specifies that each entity instance of a supertype must be a member of some subtype in a relationship. On the other hand, partial specialization rule is a rule that specifies that an entity instance of a supertype is allowed not to belong to any subtype. Uh, a page for example, is for the figure 3.6 examples of completeness constraint. A total specialization rule. This example, the basis rule is the following. Patient must be either an outpatient or a resident patient. Total specialization is indicated by the double line extending from the patient entity up to the circle. In this example, every time a new instance of a patient is inserted into supertype, a corresponding instance is inserted to either outpatient or resident patient. If the instance is inserted into resident patient, an instance of the relationship is created to assign the patient to a hospital bed. The next one is partial specialization rule. For example, a motorcycle is a type of vehicle, but it is not represented as subtype in the data model. Thus, if a vehicle is a car, it must appear as an instance of a car. And if it's a truck, it must appear as an instance of a truck. However, if the vehicle is a motorcycle, it cannot appear as an instance of any subtype. This is an example of partial specialization. The next one, disjointness constraint. Disjointness constraint is a constraint that addresses whether an instance of a supertype may simultaneously be a member of two or more subtypes. Disjoint rule is a rule that specifies that an instance of a supertype may not simultaneously be a member of two or more subtypes. The next one is overlap rule. Overlap rule is a rule that specifies that an instance of a supertype may simultaneously be a member of two or more subtypes. Next. In figure 3.7, this is the example of disjointness constraint. Okay, about the disjoint rule. At any given time, patient must be either an outpatient or a resident patient, but cannot be both. This is the disjoint rule, as specified by the letter D in the circle joining the supertype of its subtypes. Note in this figure is a class of a patient may change over time, but at a given time, a patient is of only one type. The next one is overlap rule. In this example, an instance of a part is a particular part number, not an individual part. In this case, it is not important to keep track of individual parts. When tracking individual parts is important, each part is assigned a serial number identifier, and the quantity on hand is 1 or 0, depending on whether the individual part exists or not. The overlap rule is specified by placing the letter O in the circle, as shown in figure 3.7b. Notice in this figure that the total specialization rule is also specified. as indicated by the double line. Thus, any part of must be either a purchased part or a manufactured part, or it may simultaneously be both of these. That's for me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Okay, my name is Al-Amien Rasyif, and I want to explain about a superity subtype hierarchy. The attribute shown in figure are SSN, identifier, name, address, gender, and date of birth. The entity type at the top of a hierarchy is sometimes called the root. Next, dividend all major subtype of the root. In the example, there are their subspace of person, employee, person who work for the university, student, person who the attend class, and alumni, person who have a graduate. Assuming that there are not other type of person of interest to the university, the total speciation rule applies. As shown in the figure, a person might belong to more than one subtype, alumni and employee. So the overlap rule is used. Attributes that apply superitical to each to that subspace are shown in the figure. That each of the employee has a value for the date, height, and salary, major, depth, and the attribute of student. And the next step is the evaluate wherever any the subtypes already dividend quality for further specialization. In the example, employee is a partition into two subtypes, faculty and staff faculty, and has the ephistic attribute rank, whereas staff has the specific attribute position. Notice that in the example, the subtype employee become a superiority to faculty and staff, because there are many by types of employee as other the faculty and staff, such as student, assistant. The particle specification rule in the ethic. However, an employee cannot be both faculty and staff at the same time. Therefore, the disjoint rule in the idents in the circle. Two subtypes. There are also divided for student, graduate student, and the undergraduate student. Undergraduate student has the attribute class standing. The graduate student has the attribute test course. Notice the total special intuition and the disjoint rules are special. You should be able to state the business rules for the constellation. The next is entity cluster. Number 1, EER diagram are difficult to read when there are too many entities and relationships. Number 2, solution. Group entities and relationship into entity cluster. Number 3, entity cluster. Set of one or more entity types and association relationship group into a single abstract. Okay, that's all for me. I'm sorry for my mistake. The next, Imam El Hafiz. Assalamualaikum warahmatullahi wabarakatuh.
The next is entity clustering. Entity cluster is a set of one or more entity types and associated relationships grouped into a single abstract entity type. Entity clustering is a useful way to present a data model for a large and complex organization. Because EER diagrams are difficult to read when there are too many entities and relationships, so we group entities and its relationships into entity cluster. Here is the picture of complex entities diagram. From the diagram, the related entities we can turn into cluster, such as vendor entity, supplier entity, supplies entity, raw material entity. It will become material cluster, and so the others. Because we turn complex entities become cluster, It makes the diagram become more readable. It left just a selling unit cluster, customer cluster, item cell cluster, item cluster, material cluster, and manufacturing cluster. It's more simple. So for each cluster, we can see the detail. It is the example of manufacturing entity cluster.
So next we're talking about the package or universal data model. So what is the universal or package data model? Universal or package data model is a generic or template data model that can be reused as a starting point for a data modeling project. And also people call that pattern. Package data model was predefined data models. That's why because it's started point. And package data model could be universal or industrial specific. So what are the feature and advantage of package data model? First one, the package data model use proven components. That means this data will keep up to date by the provider as the new kinds of data are recognizing in an industry. The second one, saves time and cost. The third, less likelihood of data model errors. Easier to evolve and modify over time. 8 in requirement determination. The easier to read because they are based on the common component seen in similar situation. So this make the package data model easier to read. Supertype and subtype hierarchy promote reuse. Many-to-many relationship enhance model flexibility. Many-to-many relationship make the universal or package data model be more flexible. Vendor supply data model faster. Integration with vendor application. That because the package or universal data model already support inter-organizational system. So in the end, the use of package data model can save considerable time and cost in data modeling. The skill also required for a data modeling project with a package data modeling project are quite advanced and are built on the data modeling principle covered in this text. So you have to consider not only the current needs, but also the requirement to customize in the general purpose package. And data elements must be renamed to the local terms, and the current data need to be mapped to the target database design. This mapping can be challenging due to the various forms of mismatch between the data in current database with those found in the best practice purchase database model. So this is the example of basic party universal data model, and this is the party of supertype or subtype hierarchy of package data model. So maybe that's all for me. Thank you for your attention.